How do you monitor GPU utilization and cost in cloud AI workloads? Understanding this question is like watching how hard a race car engine pushes while seeing how fast the fuel bill climbs. Performance and cost move together, and even small inefficiencies can create large expenses over time. Utilization shows how much real work the hardware is doing. Imagine an assembly line where workers pause between tasks. Everything slows even though you're still paying full price. GPUs behave the same way when workloads don't keep them active. VRAM usage reveals how well the model fits inside its workspace. Underuse means you're missing opportunities for larger, more efficient batches. Overuse leads to stalls and instability. Cost closes the loop. Cloud billing ticks forward like a taxi meter. When utilization falls behind, the meter keeps rising, which is why production teams constantly track these signals together. A strong interview answer is, I monitor GPU usage, VRAM behavior, and hourly cost together because they reveal true efficiency. If someone asks what usually drags utilization down, you can say, slow data pipelines starve even the fastest hardware. Core monitoring in the cloud is about aligning performance and cost so they rise together. This balance works the same way a well-run kitchen manages timing, ingredients, and effort. When everything is aligned, the entire workflow feels steady and predictable. Real-time metrics offer the first clues. They show utilization, temperature, and VRAM activity, much like checking a heartbeat to see how consistently the system is working. Cost tracking adds the financial dimension. Each hour of training carries a real price, and any slowdown quietly raises that number. Watching cost beside performance helps you spot inefficiencies before they compound. Resource optimization ties the picture together. Right-sizing hardware, using spot capacity when the workload allows it, and eliminating idle cards is like adjusting kitchen staffing to match the pace of the meal. Together, these layers create meaningful efficiency. An interview answer might be, I combine real-time metrics, cost visibility, and right sizing to prevent waste. If asked what alert you enable first, you can say low utilization under 50%. You're developing reliable production instincts. Monitoring GPU workloads depends on the tools that reveal behavior at different depths. Each tool contributes a unique perspective, the way pilots rely on separate instruments for altitude, heading, and engine health. NVIDIA gives you instant insight into utilization, temperature, and VRAM activity. It acts like a direct dashboard for understanding how the hardware feels moment to moment. DCGM expands this view across many cards. It exposes fleet-wide patterns so you can see issues that only appear when many GPUs work together. TensorBoard brings training behavior into focus. Throughput, loss curves, and progression over time help you understand whether learning is healthy or drifting. Cloud tools like CloudWatch, Azure Monitor, and GEE-CP monitoring add the financial dimension by tying performance signals directly to billing. Key metrics bring everything together: utilization for workload intensity, VRAM usage for batch sizing, cost per hour for burn rate, throughput for end-to-end speed, and idle time for starvation detection. An interview-ready answer is, I track utilization, memory use, throughput, idle periods, and cost to locate real bottlenecks. If asked which signal matters most, say throughput because it reflects the entire system. You're sharpening your intuition well. A production ML pipeline feels smooth when each stage supports the next. Seeing the entire journey, from data to deployment, makes it easier to understand where performance and cost originate. Ingest pulls raw data into the system the way materials arrive at a factory before assembly begins. Pre-processing prepares that data, like sous chefs cleaning and organizing ingredients so the rest of the workflow stays efficient. Training is where the GPU performs its heavy lifting. If data arrives too slowly, even powerful hardware sits idle, silently wasting money. Validation checks the model's behavior before release, much like running a test flight to ensure a plane performs safely. Deployment places the model into real use where reliability and speed matter. Any delays at this point ripple outward into user experience. Cost stretches across all of these stages. A strong interview answer is, I monitor GPU behavior during training and track cost across the entire pipeline to keep delivery predictable. If asked where issues appear most, you can say ingestion and pre-processing often hide quiet bottlenecks. You're connecting these pieces exactly the right way. Interviewers love exploring how you think about cost, performance, and stability in GPU-heavy systems. These follow-ups reveal your practical judgment more than your raw knowledge. Reducing cost without slowing performance often involves smarter compute choices, spot instances, auto-scaling, batch jobs, and mixed precision work like more efficient tools that boost productivity without reducing quality. Alerts create early awareness, low utilization, budget thresholds, VRAM overflow, and training errors behave like cockpit warning lights that help you respond before problems escalate. Comparing GPU and CPU value means thinking in cost per epoch or time to convergence. A GPU may cost more per hour, but if it finishes 20 times faster, it delivers far more value. Multi-card monitoring keeps distributed training coherent. Imagine several GPUs passing gradients like notes around a table. If one slows down, everyone waits. Tracking per card throughput keeps the circle moving smoothly. These questions test real operational thinking. A polished answer is, I combine spot use, mixed precision, utilization alerts, and per card throughput to balance cost and performance. If someone asks about common mistakes, say many people optimize the model but ignore communication overhead. You're mastering these ideas quickly. Thanks for watching this AI/ML interview series. If you found these insights valuable, please like this video. It helps others discover it. Feel free to comment with any interview questions you'd like me to cover next. And don't forget to subscribe so you never miss the next module. If you know someone preparing for AI or ML roles, sharing this video could make a real difference for them.